Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to take a look at Course 3, Functions and Slope Review Packet. This is a packet that I've assigned for some students that I found somewhere floating on the internet, and I want to create an answer key to make sure that we really understand how to solve the problems in the most appropriate way and show the work in the most appropriate way. Okay, so let's get to this. So these problems, these 4 problems are asking, is there a constant rate of change? So is there a slope? Is there a m in your y equals mx plus b for functions? So the way that we're going to find if there's a slope is we're going to make sure that the change between these two is going to be somewhat proportional in the change between these two. So for example, what do I mean by that? I know that 1 plus 1 is 2 and 2 plus 1 is 3, right? The same thing shows up here, so that kind of works out nicely. 13 plus 13 is going to give me 26, and 26 plus 13 is also going to give me 39. So my slope, I know that my slope is always going to be the change or delta y over the change or delta x. You might also have seen it as y2 minus y1 over x2 minus x1. So that does in fact have a slope. That does in fact have a constant rate of change. So in here, my constant rate of change is going to be 13 over 1. And I know that because I know the y is in the numerator and the x is in the denominator. Okay, I'm actually going to go out of order sometimes when I solve these. So just to make life a little bit easier for us to focus on the same type of problems. Okay, so going in here, I know that I'm just going to add by 1, add by 1. In here, I am subtracting 5, and then again, subtracting 5. So my slope, my n, right, is going to be -5 over +1, or just -5. And that means there is a constant rate of change here. Here, I'm going to constantly add 3. And then down here, I am going to add 21. And then again, add 21. So this one is really different, not really different, but slightly different, because when you're looking for a constant rate of change, and we're looking for this change in y over this change in x, my change in y is 21, and my change in x is 3. One thing that you'll notice about some of your slopes, like this one, we could have simplified to just 13, right? Number 3, we could have simplified to just -5. Here, we would simplify it to 7 over 1 or just 7. There are times when you can simplify your slope, and when you can, you should. Okay, so this one here, I have +2, +2. Then over here, I'm adding 4, and in here, I'm adding 6. So this is not a constant rate of change. This does not have, it is not a linear function. So this is, I think we can write none, or not applicable, or no constant rate of change. Something along those lines would be totally acceptable. Okay, so the next 2 questions ask me about slope, to actually go in and find the slope. So I know that my slope formula is y2 minus y1 over x2 minus x1. One of the things that I want you to pay attention to is that it does not matter which point you pick as point 1 and which point you pick as point 2. You're going to end up with the same slope regardless. It just might be that you're going to have a positive and a positive in the numerator and the denominator, or a negative and a negative in the numerator and the denominator. It's also very possible that your numerator might be positive and your denominator might be negative, and it might be flipped if you flip around the points. But it does not matter, because your final answer is still going to be the same. So I'm going to go ahead and take 8 minus 6 over 6 minus 5. So that's going to be a slope of 2 over 1, or just 2. So that's going to be my slope here. There are times where you may have a slope, for example, of 5/4. Please do not change that to 1 1/4. This is not algebraic, okay? We would like to leave that as 5/4. Okay, so same slope. I'm going to choose this as 0.1. This is 0.2. So I'm going to go 4 minus 8 over 4 minus 2. It's a weird looking 2. So -4/2. Simplified would be -2/1 or just -2. So the next two problems ask if there is a direct variation and what is the constant of variation. So a direct variation, simply put, just means that there is a, let me actually get rid of this so I can do some drawings. Okay, so when I have a graph, here's my x-axis, here's my y-axis. A direct variation will always have a line that cuts across through the origin. An indirect variation will always have a line that does not cut through. Okay, so for example, these two lines might be parallel, but only this line has a direct variation. Meaning I can take each of these fractions in my ratio table or in my XY table, and they will all simplify to the same thing. It also means that I will have a point. I mean, it could be in here, but I don't have room there, so I'll just put it here. There will be a point of 0 something, and that will likely be 0, 0. So if I have a point that looks like that, then I do have direct variation, and then there is a constant of variation of your slope. Not to say that, okay, I'm not gonna say it because I think I'm gonna confuse you. Okay, so in here, I notice that I'm gonna constantly add one, right? So that'll give me the opportunity to see if I have slope. So down here, every single time I'm gonna add 15, add 15, add 15. So when I go in and I want to go from 1 to 0, I know I'm gonna subtract 1. Let's see if I can do a different color. So to go from 1 to 0, I subtract 1 because I'm kind of going in the opposite direction. Maybe if actually, I'm gonna erase this and this, and we're gonna put in 0 at the very beginning. So we're gonna put 0 here, and then this is gonna be kind of my question mark. So if I know I'm adding 1 in this direction, when I move in that direction, I have to subtract 1. So again, if I know I'm moving in this direction and I'm adding 15, when I move in that direction, I have to subtract 15. So 15 minus 15 is 0. So in fact, I do have this 0, 0 point. Yes, I do have a direct variation. And my constant of variation is just 15/1 because that's my slope. So this is also known as slope, right? And so my slope or my n is just 15 or 15/1. In here, I have a similar idea where I am constantly adding 3, adding 3, adding 3, right? So if I'm moving, let me actually erase these. I don't think, oops, that's not an eraser. Okay, beautiful. So if I'm adding 3 in this direction, I'm going to subtract 3 in that direction. And that's going to give me 0. So it kind of like works out really nicely. In here, I'm also constantly adding the same amount. I add, maybe I don't add the same amount. Here I add 3. Here I add 9. And here I add 3 again. So there is no slope. But even if I were to add 3, add 3, add 3 in that direction, and I were to subtract 3 or 9, I still would not end up with 0. So no, there is no direct variation, and also there is no slope. Okay. The next 4 problems ask you to identify the slope and the y-intercept. So one thing that we really want to make sure that we understand is our slope-intercept format is always y equals mx plus b. We want to make sure that we know that m is the slope, and we also want to make sure we know that b is the y-intercept. Sometimes you will just have a y equals mx situation and your b is going to be 0. That's not the case for any of these, but it is possible that a question like that might show up on your test. Okay, so I know on here, I'm going to just highlight these. My m, which is in front of the x, so all of these are going to be my slopes. And slopes can be whole numbers, slopes can be fractions, slopes can be positive numbers, slopes can be negative numbers. Those are all of my slopes. I also know that my y-intercept is going to be a number that's on its own. Slopes again, sorry, y-intercepts again can be positive numbers, can be negative numbers, can be whole numbers, can be fractions. Those are all of my y-intercepts. So just to make sure that we have everything like fully appropriate. Yeah. Okay. Here, my slope is 4. My y-intercept is 6. Here, oops, whoopsie daisy. Here, my slope is 1/2. My y-intercept is 12. And this is really what they're looking for. Here, my slope is -3. My y-intercept is 1/4. They're not looking for, go ahead and highlight the things that you need to see. They want actual answers of M is this, B is that. Okay. The next thing that we need to look at is finding the X and the Y intercepts. So when you're given an equation, and this is considered standard form is when you have your X and Y on the same side of the equal sign. You could add, subtract, multiply. Well, you're going to multiply something by the X if it's 1 or more. The numbers in front of the X and the Y could be positive, could be negative. It's a slew of things. But essentially what's happening, and I like to do something like this. I'm going to show you right now. So imagine this is my palm. I will take this portion to cover up, I'll take my palm, I'll cover up the y portion of the equation, and I'm going to set my equation of 4x equals 20, and then I'm going to solve. Divide by 4 on both sides, x is 5. So my x-intercept is 5. I'm going to go ahead and I'm going to do the same thing for my x version, and I'm going to see that I have here 5y equals 20. So that's kind of covered up the x. And now I'm going to divide both sides by 5, and I'm going to get 4. So my y-intercept is 4. I do that like in person when I like teach things on the board. Another way that your teacher might have taught this is, in order to find the x-intercept, your y needs to be 0. So you're going to take -5x plus 2 times 0 is -10. Now, as a tutor, I like to simplify things as much as possible. As a teacher, I do need you to understand that when you graph something on an XY axis, right, your x-intercept, any point on here, will be where y is 0, which is why here I have a y equals 0 situation, and I'm going to plug it in here. But I know, and you know, because you're taking 8th grade course 3 math, at this point, you know 0 times anything is 0. So this is going to kind of like go away. So I'm going to have -5 equals -10. So then x is 2. So my x-intercept is at 2, 0, or just 2. I do like this whole bit of like just putting my palm over this thing that I don't need, and then going in and doing the work, right? So 2y equals -10, divide by 2 on both sides, y is -5. So my y-intercept is that. Same thing here, I'm gonna have 6x is 42, and -7y is 42. I'm essentially just looking at just the x separate and just the y separate. Divide both of these sides by 6, my x-intercept is 7. And here I'm going to divide both sides by -7, my y-intercept is -6. So again, -10x equals 30, -6y also equals 30. I'm going to divide both sides by -10, x equals -3. That's my y-intercept. I'm going to divide both sides by -6. Y equals -5. Solving systems. I don't think that most functions units that talk about functions and slopes have a system of equations section. I do think that systems of equations either will be coming up in a later chapter or have already been covered in a former chapter. I think this was just put in as a review. So in here, I would say we're going to set both of these equations equal to each other in a sense that we can replace this y with this information because they both equal y. So we're going to subtract x on both sides first. We're going to get 6x is 12, divide by 6, and get x equals 2. And then I'm going to take that 2 and I'm going to plug it into this easier problem, or maybe I guess both of them are fairly easy, to get our y variable, right? So when we solve a system of equations, if you've already covered it, you know that you need to have an x and a y for a solution. If you haven't covered it yet, well, now you know. So y in here is going to be 14. And most teachers don't appreciate having x equals this, y equals that as a solution. I speak from experience. 214 is the most algebraic appropriate solution. So when you're looking at an answer, if I were to look at x equals this, y equals this, I would probably not accept that on an actual test. I would prefer, and maybe I would probably give like half a point off for not finalizing that answer. So just FYI from a teacher's mouth, right? Same thing here. I'm going to go 4x equals -2x plus 3. I'm going to add 2x to both sides. 6x equals 3, divide by 6, x equals 1/2. Oh, so gross. I love fractions. Actually, I really do think fractions make more sense than decimals, but I'm always not a fan of seeing fractions and answers when the students are taking courses that are non-high school courses. So I'm going to go ahead and I'm going to choose this equation to plug the x back in because I actually do know that half of 4 is 2. So that kind of makes my life easier. Again, here is that final answer, but I can't leave it as is. So I'm going to go 1/2, 2 is where these two. I hope that this was super helpful and not at all boring. And I look forward to seeing you in the next video. Bye.